Well, good day everyone, and welcome to Warehouse 14. And in today's installment, I think we'll have something that might be of interest to you. So let's just go on in and see what's going on inside the warehouse here. And as we look over the shelving here, I don't see anything we haven't seen before. Let's go down here. As I heard a rumor that somewhere down here there's a service case to a world famous IBM customer engineer that he carried around for 20 years. And inside that case we have a very interesting artifact here, and it's a old volt-ohm-meter. And if we open it up and take a look at it, let's see what we've got here. Oh yes, looks like we might have the IBM version of a Simpson 160. And as you can see, pull it out of the case here, that it is indeed modeled after the Simpson 160, but it was produced for IBM around 1980. And they probably produced several thousand of these things for the engineers to carry with them and do service work. And so I thought we'd take a closer look at it, and I can see already that up here in the corner we've got some damage to the plastic face. We'll see if we can repair that, or at least keep it from continuing on with more damage.
I am depressed.
And then maybe recalibrate it and see how well it works for a while.
I'd love to tear this baby apart.
And we'll see how well it held up after 40 years of use. And we're back on the warehouse bench with the meter, and what we're going to do now is see if we can get the plastic bezel off of this thing. And we'll try and repair it. And what you normally do is take the screw out of the back slightly and give it a push, and that'll kind of free up the meter movement. And we'll take the screw out. Now this screw is not the right one for this meter. It had a plastic one in here probably to keep the meter movement more accurate, but all I have right now is this old Phillips, so we're gonna see if we can find that later. And we'll pull the movement out here, and we can look at the meter face, and the whole thing just pops off right here. Just give it a bit of a tug here. Get the right tool, and there we go. And we'll pull that off like so. And we'll set the meter away in a very safe place, because right now it's fully exposed and very susceptible to damage. So let's put this away in a safe place, and we'll get back to see if we can do something about all the cracks in the movement here in the meter face. So we'll be right back. Okay, now that we have the movement stowed away in a safe place, we'll go ahead and begin repairs of the cracked case. I noticed this one also has a crack in it in the back side. We'll just remove this calibration sticker, put him away, and I think that crack goes all the way up to here, so I think we'll go ahead and stop drill it. We'll turn on our magnifier here so I can see a little better. And get out our trusty Dremel tool with the absolute smallest drill bit that I can find in my pack, and it's 0.30 millimeter. And you can use anything you want, really. It just depends on how big a hole you want to make in it. But what you want to normally do is drill right at the end of where the crack is, or where you believe it to be. And we'll go ahead and start that up. And all you headphone users out there, pull your headphones off, because it's going to get loud. Now we'll go ahead and work on the meter face. Okay, I think we have all the holes drilled now. We can take a look here. And I think what we might try to do, and at least I'm going to do it on the back part of this, is maybe put a little CA glue in there and clamp it using a pipette or something. Maybe put a rubber band around that hole. I don't know if I want to use the CA glue on the face or not. That stuff tends to fog clear plastic, and would end up looking worse than the cracks. So if I do, I'll probably just do it on the edge here. I don't think I'll touch the front. I just don't see the end result being all that great, and then it's pretty irreversible once you ruin it. So we'll go ahead and get the glue ready and come back and start filling in some holes. Okay, so I've got a little bit of CA glue here, better known as super glue, and I'm going to squeeze out a drop here in this container, and put the top back on it. And it's just cheap old CA glue. And what I do have is some pipettes. Now I have this small one here that if you look at it, it's very thin. I started out with this one and from a local hobby shop, and to make it thinner, I just put a guitar string inside of it, heated it up, and pulled the nozzle back, so it made it a really fine thing here. We'll see how well it works. Yeah, it does seem to pull up the glue pretty well. So we'll just drip a little in there, or try to get a little in there. We'll pull it apart as much as we can and get that in there all the way up to the drill hole. Hopefully you can see that. And we'll clamp together with a rubber band, like so. And then we'll set it aside over there or let it dry overnight. Then I'm going to try this on the very edge here to where it won't be so noticeable if it does go bad on us. So I'm going to just put a little bit in there. And maybe some right here. I think I managed to get my finger on the side of that, which is the other reason I really don't want to do that on the face, because I'm going to set that down, put a little bit of weight on it. And we'll let that set, come back and see how it turned out. Well, it's been a good appropriate amount of time to let the CA glue dry, and I just thought I'd show you what it looks like now. I'm really glad that I decided not to put any on the face of the bezel here, because if you'll notice on the side, you can see where it really kind of fogged the acrylic where we had the squeeze out of the glue, and a little bit there too, and some there too. It's good and solid now, but I don't really like the way that really fogs that. So I'm glad all I did was stop drill this. And also, when we were done doing that, I went ahead and polished out the scratches in the bezel here, and also in the back of the meter. So that came out real nice. And what I used for that was some of this Novus number 2 fine scratch remover. It will get rid of all the minor scratches. The major ones are still going to be there, but it does make it look a lot better. So let's go on to the next phase of our project, and that is to, before we do anything else, we want to put the bezel back on the meter so as not to damage this. But before we do that, one thing you want to check is the balance of the meter, and you do that in the vertical position, zero the needle up, and then set it in the horizontal position and see if the needle zeroes out. If it does, the meter is well balanced, and if it needs some balancing, what you'll have to do is, if I can get something here to point to it, at the very bottom of the movement, right here, you can see that there's what looks like a little coil spring. It's basically a counterweight for the meter movement. If you just blow on the needle, you can see it move there. But the way you would balance this is, if it won't center from the vertical to the horizontal position, just move that little counterbalance in or out with some hemostats or tweezers or something, and that's how you balance it. Just kind of a hit and miss thing, trial and error. And this one I didn't have to touch, so I was happy about that. And the next thing we want to do now is put the face back on it. So let's do that before we damage anything here. And oh yes, don't forget to line up the little pawl here that sticks out. See if you can see that. You'll have to line that up with the fork at the bottom of the movement here. And that's securely in place and protected now. And we can go on to the next step, and that was to, and I've already done this, we went ahead and cleaned up the switch. And what I used for that was, instead of some switch or contact cleaner, I just used some CRC mass airflow sensor cleaner. It's almost identical to the CRC switch cleaner, but it's a little, has a little better purity to it, and it does not leave any residue whatsoever. And whenever you're dealing with test equipment, especially an oscilloscope, you don't want to really use any cleaners that will leave behind a residue or an oil film, because that can throw off the calibration for quite a while until that evaporates, and then you'll have to go in and recalibrate it again. So I just use this stuff here. It's a little more expensive than a switch cleaner, but I've got a lot of it handy. So I really like the way that turned out with the Novus plastic polish. And basically all you have to do is to polish that is with a lint-free rag or cloth, just
Wax on, wax off.
and that's all it needs, and you're done. So let's go on to the next section, and I think I also want to put a little lubricant in the bottom of this, and I have a glass syringe here filled with Super Lube, which is a synthetic grease that, if we can get in there, I don't know if we can see this on camera or not, probably not, but we'll apply some in there to where the detents are for the switch. And then give that a rotate around a few times so it's nice and evenly distributed. And yeah, another thing we'll want to look at is the condition of the batteries. And let me get a screwdriver out here. And we'll take a look at what this one Simpson 160 has for batteries. And it's a little unusual, I can tell you that right now. The first one for the lower ohm scale is, I think it's a lower ohm scale, and too bad it's just a standard AA. Make sure it's not leaking and hasn't gone by its expiration date like this one has, 2017. And the other one in here is a 22.5 volt battery, which is going to be really hard to find these days. This one's been in there since 2005, as you can see. But it's a number 505 or Anita 221 battery, and it's a 22.5 volt battery. And I'm sure you can find it on the internet somewhere. This one's not leaking, and if it ain't leaking, I'm not going to touch it. I'm not going to throw it out because it might be pretty hard to find somewhere. So we'll just go ahead and put that back in with the plus on the top and the plus on the top on this one. You don't have to tighten it real tight, just enough to make contact there for a quick way to check it. Will be go to the ohm scale, we'll go to the ×1 and cross the common with the plus. And yep, that works. Let's go to the next scale, see if that also has plenty. That too. And yeah, we've got good batteries in that for now. So, all right, well, let's go on to the next section, and that will be the calibration. Before we begin our rudimentary calibration procedure on this meter, I wanted to circle back to the faceplate on it and give you a little bit of a warning that you may not know about. And whenever you're working on a meter face that's plastic especially, a lot of times a manufacturer will coat the inside of the plastic with a anti-static coating so as to not reduce the accuracy of the meter because of needle sticking in different places of the face, usually around the 0 mark. But a lot of manufacturers will do this, so I wanted to caution you, especially if you own a meter similar to this one here on my bench, the VTVM built by Heathkit. And I think RCA also does this. They'll coat the inside of the face of the meter with an anti-static coating, which can be removed if you clean it too aggressively. So I wanted to caution you, be careful when you take this faceplate off, not to be too aggressive with cleaners inside. The most I think I would do, unless you have a compelling reason not to, is to just blow the dust off of it and not wipe it down with any harsh chemicals or anything like that. Because if you do take that anti-static coating, you might have a problem with the needle not zeroing or its accuracy being greatly reduced. So I just wanted to warn you of that. And in the meantime now, we'll get back to our calibration procedure on this meter. And before we begin, I wanted to show you that I was fortunate enough to still have the operator's manual for the meter. It gives you a really basic idea of how the meter functions work, which is nice to have if you can get one. But it also has a really nice schematic in the back of it that I was able to blow up and reproduce with help of the good folks at the radiomuseum.org. And I wanted to show you a couple of things here about calibrating this meter. But before I do, I wanted to say that I am not a professional meteorologist, as they say, and I don't have any true calibration instruments. So this is just for your edification only, and so if you really want to be a stickler on accuracy, you might have to go somewhere else, but I'll show you as best I can what I found out how to calibrate this. And there's really only two sections to calibrate. One of them is the meter's shunt resistor here, R2, and its series resistance, which is R1. Now, these two adjustments will affect only the milliamp and microamp section of the meter. So once you get these adjusted, your DC section will also follow suit by the aid of these precision multiplier resistors. There's no other adjustment here except those two. And then once we're done with adjusting the DC part, we can move over to the AC area. And there are two adjustments here, one for the low end of the scale and one for the high end of the scale. I can't remember exactly which was which, but we'll deal with that later. So these two resistors here variable resistors will calibrate the AC ranges, and also through the use of the precision multiplier resistors, that's how you'll get your accuracy on this. So I just wanted to tell you that I have hunted for days and days on the procedure to calibrate a Simpson 160, and I could not find anything on how to do it. The closest I could get was a Simpson 260, which the schematic was very, very similar, but for some reason when I went to adjust the shunt across this, it didn't make much difference going from one end of the potentiometer clear to the other. So I'm not sure what was going on there. But the R1 resistor here is really the one that you have to adjust to make any appreciable difference whatsoever in the reading on the meter. So I would suggest that before you start on this calibration is to mark, as I did, the resistor positions. And there's one here that I marked there and here, and also on the AC side I marked them. So if you feel the need that you have to go back and do something about that, then you can return to square one, so to speak, and not do any damage to the previous calibration of the meter. So that being said, we'll go ahead and we'll begin doing the DC part here. And what you'll need is some kind of a direct current source. And I have one here. It's on my bench. It's up here in the corner. It's this DC meter here, or DC power supply, and it's 1.8 to about 30 volt DC. Now, that's quite a range, but what I have to do after that is, in series, I have a Heathkit resistance substitution box, which will lower the DC current down to the lowest reading on the dial here of 0.6 milliamps, which is 600 microamps. So we'll go ahead and get hooked up here, and we'll get the meters all set up to where we can read a full-scale reading of 600 microamps with the switch down here in the microamp on 0.6, as you can see right there. So we'll go ahead and get this set up. Now, with everything all hooked up in series, going from the power supply through the resistor substitution box and through our calibrated, and I use the term loosely, digital meter here, and still in series going through the IBM meter, we'll go ahead and we'll just this power supply. We'll turn it up and we'll see if we can get a reading of 600 microamps, or as close to it as possible. And we're getting pretty close. 598, 599, 600. Okay. And we're a little high on the meter here, as you can see. And of course, the first thing you want to do before this is to zero, which I already have using the zeroing screw here. And we will adjust R1, which I have marked ahead of time here. Get this marked there. For 600 microamp reading. And that is right there. Now, and that's really all there is to it. You can check the other ranges by moving up to that one. And okay, this is on the 6 milliamp full scale reading. So let's turn this up to milliamps. And let's give her 6 milliamps and see how close we are on the range here. Now we've got the resistor substitution box turned to I think it's about 680 ohms in that area. That should give us enough to bring her up to 6 milliamps. Just to see how close we are on this range here, 5.9. And there is 6 milliamps, or as close as I can get to it. And looking through my calibrated eyeball, it's right at 6 milliamps. So that range is good. And now we'll go to the 60 milliamp scale. And check its range here. Of course, if it's not in range, there's not a whole lot you can do about it except change out the precision multiplier resistors. Okay, we're at 60.2, and it's just a little bit low on the meter. Try to get that a little closer to you, but I don't want to get a reflection off the lights there. There we go, there's 60, and it is right on the money. Okay, I must have been reading it wrong. Yeah, it's right at 60. Okay, now let's go up to the 150 milliamp range. And we're still at 60, and on the 60 mark here, let's back this down to get it at 60 milliamps. And I don't know if you can see that too well or not, but it is right on 60. Which would be the 6 down here and transferred up to the top scale, like they say to do on this, and it's right on the mark. So we can probably bring that up to, let's see if we can go any higher in my resistance. On the mark, and it is exactly 150 milliamps. And we'll go to the 600 range, and we are at 120, 20, 25, 30, 35, 40, 45, 50. And it's right on the money. So I don't know if we can go too much higher on this. Let's see. Oh, we might be able to get 600 milliamps out of it. Nope, can't make it. Try that one. I think 600 milliamps must be the limit on my meter. On this meter anyway. It starts squawking as soon as it hits it. There we go. And it's showing 600 milliamps right here. So let's back it off. Okay, so I think the multiplier resistors are just perfect on this. And we have adjusted R2 on the schematic here. I'm sorry, R1, which on the side of the meter, if you can see it there, is this pot right here. So R1, and that takes care of the calibration for the DC scale. And for the AC scale, I'll go ahead and tell you right now, I've got something unique set up to do that. And okay, for our AC calibration, we have a setup here that requires we use almost a 0 to somewhere in the neighborhood of 400 volts, according to what I've got off the internet on how to adjust this using these potentiometers here. And it says to adjust this, I think it's R3 for the upper scale of the 600 volt range, and then R4 for the upper scale of the 6 volt AC range. Now I've got set up a high voltage transformer of an old, I think it's out of just an old radio that will put out around 400 to 500 volts AC, and powering it through a variac so I can adjust the voltage to whatever I need. And also up here a little higher, you can't see it, it's kind of hidden here, but there's a dim bulb current limiter. Let's see if I can get over, there we go, a dim bulb current limiter right there, just in case I get my wires crossed, and we won't damage anything, because I'm not sure on this transformer what its state is. It could be totally shorted for all I know, but we're going to find out here right quick. And so we'll get back on our meter. I've got all the connections made, I think, and we're going to go ahead and turn the variac all the way down, and I'm going to set the meter on 600 volts AC, and we'll turn on the variac. There we go. Now we're getting readings on both meters. So let's take her up to about as high as we can get. Yeah, we're on the high voltage tap. Okay, we're at 459 volts. There's 500 volts. Now they say in the directions to get as close as possible on the upper scale of 600, on the 600 volt scale. So let's, there's 500 and right at 550. And on the meter we are seeing 492 volts. So we're going to do a little adjusting here on, what did I say that was? R3. I'm going to take it down to 480 just to be sure I'm reading that scale right. about as close to 480 as I can get, so. Okay, so we're at 480 right there. Okay, and then they say to bring it down to 6 volts, as close as you can get to 6, and we'll change the range. That's 5.1. There's 5 on the money, so we'll adjust the other potentiometer back down to 5 volts. Right there. And then we'll, let's go ahead and take it back up to 600 and see if that is still tracking right. 480 volts, 85. There's 480. And we'll readjust this other pot a little bit. Looks like they interact somewhat. 400. Okay, that's 480. Let's take her back down to 6 volt range. And at 5 volts. Just a little bit high yet. About right in there, I think we have. Back up to here and see what we got it. $480 volts, right on the money. And down here, 6 volts AC, right on the mark. Okay, looks like we've got the ranges all set now. So we'll go ahead and turn off our high voltage equipment and unplug everything so we don't make any fatal mistakes here. Well, that about does it for today's video, and I want to show you a couple of things. I did put some marks on the pots here where they originally started out, and if you can see that, you'll notice they're not exactly where they were originally from the factory, and especially on the AC scale, they were off quite a bit, but it did adjust up really nice and really well. The meter is just absolutely accurate, and it really impressed me. I've never had an analog meter turn out this well as far as accuracy on all ranges and on throughout the entire scale. It's just right on the money, and that's about the first time that's ever happened to me doing something like this. And so I did a little more investigation on how to adjust the shunt potentiometer here, which is R1 on the schematic. And as you can see here, I'll just raise this up so you can see it a little better. R1 here. I think the best way to do this, and the best way it worked out for me, obviously, is if you set the meter to the lowest milliamp scale, which on the meter itself is 0.6 milliamps, which equates to about 600 microamps. If you'll set your meter there and adjust the pot R2 to full scale and apply a 600 microamp current through it at full scale, you will see that when you switch from that 0.6 volt range there on up to the highest range, which is 600 milliamps, and then adjust R1, which is this potentiometer, to a full scale reading of 600 milliamps, everything will turn out just perfect. And I think that's probably the best way to do this. Well, I think we can go ahead and box this up, put the cover back on and all the screws in place here on this meter. And once we get that all in place, we'll go ahead and put it back in the service case and put this artifact back on the warehouse shelf and look around for another project to do next time. So once again, thank you for watching, and please hit the like, subscribe, and ring the bell button. I would appreciate it, and any comments you might have also. See you next time.